probably not the one that started moving before I even got to the zone, right? I have to establish what that resistivity, the corrected resistivity is. So don't just, when you're looking at the logs, look at the zones above and below the zones to establish what they might be doing. If you have a low resistivity zone that you're calculating, but it's surrounded by high resistivity zones, probably the number you're looking at on the log is a little too high, right? Because it's being affected, remember the cloud? It's being affected by those zones above and below it. Now if your pay zone is 20 foot thick, if you're lucky enough to have one of those, then probably that resistivity value you're looking at is fine, right? But unfortunately in Kansas, most of the time ours are a lot thinner than that, right? And we have this situation where we have high right next to low resistivities. So you have to always in your mind be aware that this could be happening to you, okay? And it's not like it's real complicated. You're just looking at it. You're just visualizing this. What does it look like around my zone? Okay? If I'm surrounded by high resistivity, for instance, everything around me is 100 ohms. My pay zone is 5 ohms. Probably 5's a little too high, right? I mean, that's as complicated as you need to make it. It's probably a little high, so maybe I need to use a number that's a little bit less. And if I flip that over, if I'm surrounded by low resistivity zones, for instance, everything around me is 5 ohms, but my pay zone's at 20, it's probably a little low, right? So it's real simple what the thinking process is. Probably need to use a number that's a little bigger when I calculate my logs. Now we're getting to where I'm really going to end up, because this has become pretty important, especially in my interpretation process. And these are things that have been around, again, for a long, long time. Something called a movable oil plot. And really all they're tied to is that image that we saw for the resistivities, the Schlumberger picture that I showed. What do those rings look like? Is what are the different calculations for fluid inside of each of those rings, okay? If I can do that, I can determine what kind of movable oil I might have in my reservoir. Well, if I have movable oil, haven't I kind of won the battle, if you will? Isn't that what I'm trying to determine? So if I can really work with this, I'm probably going to be making most people happy at this point. Now there are other things we'd like to know, but really aren't we concerned with what's movable and what's not in our business? And the saturation calculations are the same. It's all Archie's type definitions. We just use different subscripts because we're talking about different portions of the wellbore. When we're away from the wellbore and we're uninvaded, nothing's disturbed the formation, we call it SW, right? If it's very near the wellbore, it's been affected by the mud, we call it SXO. These are just terminology things, okay? So you will have trouble getting used to the names, I understand that, but it's still the same thing. It's the same type calculation using a different portion of those logs for the calculations. So if we can establish what the saturation is near the wellbore and then far away, then I can start to determine what the movable component of the hydrocarbon is, okay? And you'll notice down at the bottom, this is all coming from workshops that were put on by the guys that are here from KU. And it's still that component that we're talking about. This is basically what the plot is doing. You're working with formation water, movable hydrocarbon, and residual hydrocarbon. That's what you're establishing. Okay, now you can put it on paper, and if I can do that, then I can all of a sudden assign colors to it, right? We've got computers now, so my water becomes blue, and everything else has an assigned color. So we're getting to that point when you look at your interpretation where you don't really have to worry so much about what the number is what color is it, okay? If it's mostly blue, it's probably wet, right? It's kind of a no-brainer. If it's mostly light green, that's good. So it becomes very simple. We don't have an oil, water, gas tool, but we got something that starts to approximate what we're trying to do. And here's one of my favorite slides, I guess, because this is, how do I want to put this? Okay, there's water saturation, and then there's water saturation. Okay? Who made the calculation and what kind of parameters went into it? Okay? If guy A calculates it and gets 43% water, but guy B calculates it and gets 62% water, which one's right? What do the numbers really mean? By definition, we simplify, and we're going to always do this, we simplify things like the saturation for oil is just 1 minus the saturation for water, right? Either it's water or it's hydrocarbon, okay, inside the formation. In terms of working with logs, we call that SO and SW. SO is equal to 1 minus SW, okay? Then if that's the case, then if you have a change in SWs from 0 to 100%, on the left side of this, it's going to be all oil inside the formation, right? These numbers that we calculate. Somewhere in the middle, it's going to be oil and water, right? These numbers that we come up with. And off to the right, it's going to be all water. The key is, where does that really happen? Because it's not a specific number, because again, we've got this range of who did it, what kind of parameters went into it. This change from oil to oil and water can be happening in terms of your numbers over a spread of numbers, right? When you're calculating it. So you always want to remember this. Just because I have 45% water, or just because I have 40% water, that doesn't mean that's 100% oil as far as production goes, right? It can be oil and water. Extreme cases, it could be water, okay? So this is a moving number. This is a moving, if you will, picture. And it just depends on the formation that you're working with as to how far it's moving. So these aren't critical numbers in terms of what we're doing right now. They're just numbers. Now the more you do of these, and the more of the reservoirs that you have to work with in a given area, they become more important, right? Because then you establish where these cutoffs are for your reservoirs. But this is really important to remember this. This is where I get to the point. There was I like to use this guy's history because I think it's pretty funny. One of the log analysts, who used to be the chief log analyst for Amoco in Denver, who was an ex-Schlumberger guy, before he retired, he was kind of the guy. Even as big as Amoco was, if you had a question on your logs, you went to see Jim. That was his name. You went to see Jim. Been around forever, and he's the guy that had all the answers. He's the log guy. But if you ever went to see Jim and you had these logs, you always found out that when you went into Jim's office and he got the logs down and you're asking him questions, he'd always lean over and he'd pull out this drawer, looked at something. You didn't know what he was doing. Looked at something, because most people didn't know what the logs were doing anyway, and they just wanted Jim's answer so they could leave and go to work. And then he'd come back and he'd tell them what he thought. They'd leave and they'd go talk to their buddies and they'd say, well, what did Jim do? He said, well, he did the same thing. He leaned over there and looked at something, came back and gave me an answer, and I guess it's right. I don't know. And he had this sheet of paper when he retired. He retired in like 1979, went south to Texas to get warm. Leaves the office. What's the first thing everybody does? They run down to the office to find out what's in that drawer, because he had to have some secret in there. And this is what they found, a piece of paper. Shows SP to the left, gamma ray to the left, resistivity to the right, and porosity to the left. There's his big cheat sheet. After all those years, everybody thought he had something special. That's why he retired, probably. No, he retired because he had plenty, and he was a nice guy. But he was the guy.